My name is Briony Horgan, and I'm an associate professor of planetary science at Purdue University. We were incredibly excited to find evidence of past habitable environments on Mars in the volcanic rocks on the floor of Jezero Crater. We went to this crater to look for signs of ancient life, to look for signs of ancient habitable environments, and when we landed we found that the floor was covered in these ancient lavas, right, which is not the kind of rock you expect to find signs of life in, or signs of even ancient water. However, when we got up close and looked at these rocks in more detail, we found that they contained signs of lots of water that had once flowed through them, possibly hot, steamy, ancient habitable environments that had once coexisted with these rocks and could have supported life. So that's exciting because it's telling us that even in these kind of barren volcanic rocks, that they could have once supported life. So there are lots and lots of places that life could have lived elsewhere on Mars too. So about 3 or 4 billion years ago, we think Mars was a much more Earth-like place. You can imagine standing on the shores of an ancient lake in Jezero Crater. But the thing is, there wasn't always a lake there, and that's what our findings in the crater floor told us, is that, well, right now we're roving through this ancient delta environment that formed when a river flowed into the blue waters of Jezero Crater, that at some point that lake dried up, and that, huge volumes of lava once flowed across the crater floor. So we're really excited that even our first results from these first lavas in the crater floor are telling us about ancient habitable environments, because that's really just the beginning. Since we explored these lavas, we've since moved on to exploring an ancient delta environment in Jezero, which is where a river intersected a lake and laid down lots of sediments. Those sediments, we know, especially in deltas on Earth, are fantastic for preserving signs of ancient life, in particular for preserving ancient organic matter. The really muddy stuff you find at the bottom of a lake on Earth is typically chock full of organics, and that's exactly the kind of rock we're trying to investigate now in the delta in Jezero. So one of the things we're really excited about with our work to try to find signs of past microbial life on Mars is that it may help us better understand the origins of life on Earth. One of the problems we have is that we just have no rock record from the earliest part of Earth's history, back when life was first getting started here on Earth, about 4 billion years ago. On Mars, we think that the rocks that the rover is on right now are probably about that old, and they're just sitting there waiting for us to go investigate them. So if we find evidence that there was in fact microbial life on Mars, that's opening up a whole new field of science for understanding the early origin and evolution of life that we can really only do on Mars. So we're pretty excited to keep going down that path and seeing if we find signs of life in Jezero Crater.